Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So previous sessions have studied about wear and surface treatments in engineering tribology modules. Now in this session, I want to again explain numerical problems related to this wear and surface treatment. So revision of numerical problems. The problems on wear and surface treatments. So you know the wear and friction and lubrication is very important parameters in engineering tribology. In tribology subject involves these three parameters. So that's why every design engineer should know about friction properties, wear properties, and lubrication properties, and also how to calculate the wear rate and how to calculate the frictional force. So already how to calculate the surface roughness already we have seen in a previous session. So in this session I will explain some problems with the solution. Problem number 1, calculation of wear rate steel pin slides against steel disc under dry conditions. Two conditions are there. One is wet and another one is dry condition. So one is with lubrication and without lubrication. So calculate the wear rate. The applied load is 200 newtons. The sliding distance is 500 meters. The volume of material worn away is measured to be 0.02 centimeter cube. So calculate the wear rate in terms of volume loss per unit distance. So wear rate need to calculate. So in this actually this wear will measure experimentally by using pin on disc. A pin slides against a steel disc. Here also given a steel pin and a steel disc given. So applied load is 200 newtons. The sliding distance you can adjust. The given distance is 500 meters. So the volume of material already given. The calculate the wear rate in terms of volume loss. So the given load 200 newtons. The sliding distance 500 meters. The volume of material worn away is 0.02 centimeter cube. So that is 0.02 into 10 to the power minus 6 meter cube. This one 0.02 into 10 to the power minus 6 meter cube. The wear rate is given by W is equal to V upon L. So here substituting the values, the volume given and L also sliding distance. So the wear rate, the volume is equal to volume of material is equal to wear rate multiplied with L. So substituting the values, W is equal to V upon L. V given 0.02 into 10 to the power minus 6 upon L. L is this value is this one and L is equal to 500 meters. So finally you will get 4 into 10 to the power minus 11 meter cube per meter. Similarly problem 2. Determination of specific wear rate. A material undergoes a wear test where a load of 150 newtons is applied. The sliding speed is 2 meters per second and the test duration is 30 minutes. So load 150 and the sliding speed is 2 meters per second and time is 30 minutes. The mass loss of the material after the test is 0.05 grams. So the density of the material is 7.8 gram per centimeter. So calculate the specific wear rate. So here apply these formulas for this problem solution. The given are first write down. The load is 150 newtons and the sliding speed, it is V, 2 meters per second. Test duration in terms of minutes and then convert into seconds. 30 multiply with 60. And the mass loss is equal to 0.05 gram. So 0.05 gram is 0.05 multiplied with 10 to the minus 3 kg. The density is 7.8 gram per centimeter cube. So these are the given data. So now you need to calculate the density of the material. They calculate the specific wear rate. The specific wear rate is given, the formula is K is equal to V upon force multiplied with L. Force means that is load. But V is volume loss. So volume loss can be mass loss is given, but need to calculate volume mass. So volume mass calculate, that is delta M by density, rho. So we will get 6.41 multiply with 10 to the power of minus 9 meter cube. The sliding distance is L is equal to V into T. So L given, the sliding distance, not given the sliding distance. Sliding speed is given. So the sliding distance L is equal to V into T. So V is 2 meters per second and T is 800 seconds. So we will get 3600 meters. The specific wear rate is given by V upon force multiplied with L. Now substitute this value in this equation. You will get specific wear rate. Next, calculating wear rate. Here one more problem given. A steel pin is sliding against a steel plate with an applied normal load of 100 newtons. A sliding distance here given 500 meters. So in the previous problem, the sliding distance not given, sliding speed is given. So the mass loss of the pin is given 0.5 gram. Calculate the wear rate in terms of volume loss per unit distance. So given data, so first convert the mass loss to volume loss using the density of steel. So use the wear rate formula. So the wear rate is volume loss upon sliding distance in normal load. the wear rate, that is K, volume loss V by sliding distance L multiplied with the normal load force. The given V is volume loss is here volume loss not given. Volume loss of the density of the steel here given for 7.85 grams, and L given, that is 500 meter, and then force that the load is 100. The force is 100 Newton. Clear? So now you can calculate the wear rate. Surface hardness increase due to heat treatment. So based on this heat treatment, the surface hardness, the heat treatment problem here given the steel specimen has a surface hardness of 200 HV before heat treatment. So after carburizing at 900 degrees centigrade for 8 hours, the surface hardness increases to 600 HV. So to enhance the property, maybe hardness or strength, some heat treatments are required. So carburizing, nitriding, annealing. So based on this heat treatment process, the given problem 200 HV before heat treatment. After heat treatment means the treatment type is here carburizing. Is 900 at 900 degrees centigrade for 8 hours. The surface hardness increases to 600 HV. So now calculate the percentage increase in surface hardness. So the solution is percentage increase is equal to final hardness minus initial hardness upon initial hardness multiplied with 100. Percentage increase. The percentage increase is equal to the final hardness. So you can write H final minus H initial upon initial hardness multiplied with 100. So we will get the percentage increase in surface hardness. So apply this formula, you will get percentage increase. So here the given values initially the final one is final surface hardness is 600 HV minus 200 divided by initial 200. So 400 by 200. That is 2 multiplied with 100. The percentage is 200. So next corrosion rate calculation. A steel plate exposed to a corrosion environment losses 0.5 mm of its thickness in 2 years. Calculate the corrosion rate in miles per year. So the corrosion rate MPY, thickness loss upon time in years. Convert the thickness loss to 1 mile is equal to 1 mil is equal to 0.001 inches. So mils per year means the substitute the values and calculate the corrosion rate. Thickness loss given 0.5 mm and the number of years given 2. So 0.5 by 2. So you will get 0.25. So mass loss due to corrosion copper pipe with a surface area 0.5 meter square. 0.5 meter square is exposed to an acidic solution. After 1 year, the pipe loses 10 grams of mass due to corrosion. Calculate the mass loss per unit area, gram per meter square. Its mass loss per unit area is total mass loss upon surface area. So here, substitute those values in this equation, in this formula. Total mass loss upon surface area, 10 grams by 0.5. So we will get mass loss per unit area. So here 20 you will get. Galvanic corrosion rate. An aluminum alloy is coupled with copper and seawater. The potential difference between the metals is 0.7 volt and the resistance of the electrolyte is 0.1 volt. Calculate the current flowing between the two metals and estimate the corrosion rate of aluminum if its area is 0.02 meter square. So this is a problem based on galvanizing process. So in this, the aluminum alloy is coupled with copper in seawater. The given potential difference 0.7 and resistance also given 0.1. What he has asked, calculate the current flowing between the two metals and area, estimate the corrosion rate if the area is 0.02. So calculate the current using Ohm's law. V is equal to IR, and from this equation I is equal to V by R. Use Faraday's law to calculate the mass loss of aluminum, considering the current and the electrochemical equivalent. Next, pitting corrosion depth. So a stainless steel tank is subjected to pitting corrosion, resulting in pits with a maximum depth of 0.3 mm over 5 years. So calculate the average corrosion rate in mm per year. The corrosion rate is pit depth upon time. So what is the time we are given? 5 years. Pit depth is 0.3. Clear? So here 0.0 corrosion rate is 0.06. Electrochemical corrosion calculation. So a metal structure in seawater experiences uniform corrosion with a current density of 5 into 10 to the power minus 7 ampere per centimeter square. If the equivalent weight of the metal is 27.93 gram, calculate the corrosion rate in millimeters per year. So use the following formula for corrosion rate mm per year, that is K into I into EW by upon density, where K is a constant, that is 3.27 times, that is into 10 to the power minus 3. I is the current density and EW is the equivalent weight and rho is the density. Substitute the values and calculate the corrosion rate. Next, contact pressure calculation. Two cylindrical rollers with diameters of 50 mm each are in contact. Whenever two cylindrical rollers are in contact, what is the pressure between these two rollers? The applied normal force is 2000 Newton. Calculate the contact pressure if the contact area is approximated as a circle with a diameter of 5 mm. So contact pressure is equal to normal force for contact area, and convert the diameter of the contact area to radius, and then calculate the area and substitute the values. So wear rate calculation. So already we have seen in the previous problem. A sliding test is conducted where a steel pin weighs out of a 0.2 mm over 1000 meter. Calculate the wear rate in a meter cube, mm cube per meter. So the wear rate is volume loss upon sliding distance. To find volume loss, assume a cylindrical pin and use the pin's diameter and wear depth. So next, numerical problems related to loss of wear. So it is based on Archer's wear law equation calculation. So in this, he has given wear rate and normal load and sliding. Already we have studied in the previous slides problem. Calculate total wear calculation we have learned. So apply this formula, wear rate and multiply with the normal load into sliding distance. And we are using Peters law. So one more this wear volume upon normal load into sliding distance. So in this, according to this law, material wears rate is 0.01 mm cube per Newton meter under the load of 100 newtons and distance 1000 meter given, and calculate the wear rate. If increased 150, similar problem we have studied in the previous session. Estimating wear volume also we have learned. So normal load and sliding distance, wear rate and load difference, cumulative wear calculation using law of wear volume calculation, wear test, and impact of sliding speed on wear. This one also we have studied. Wear rate and wall rate. Clear? So hardness and carbonizing depth calculation. So these are the references I have taken for this PPT.
Like, share and subscribe. Hit the bell icon for more updates.